Hey yo, what's up my little coders? In this tutorial, we're going to create a simple REST API with the help of a Spring Boot. This REST API is going to support main HTTP methods such as get, post, put, and delete. And it's also going to be integrated with a Mongo database. And we're going to host this Mongo database on a cloud. But don't worry guys, it's not going to cost you anything because the great MongoDB folks offer a free access to a shared cluster so that people can learn and export their product. So if it sounds good to you, get your keyboard ready and let's get started. To create our free Mongo database, we can just simply navigate to this URL. Then we can just select our free shared cluster and press on a try for free button. After that, you can either create a new account or sign up with your existing Google account. In my case, I would choose the second option as it's going to be the quickest one. Here, let me quickly answer some questions. Then let's click on the build a database button. Alright, I don't want to pay anything, so here's my free version, which I'm going to select. And then let me just click a create button, simply as that. Here are my login and password details for the cluster. Let me store the password quickly because I will need it later on. Also, only my current IP address is eligible to connect to the Mongo database cluster. We can modify it later on if we need to, but for now let's keep everything as it is and let's click on the finish and close button. Alright, now our cluster access is basically ready, so let's quickly create a Spring Boot project. For that, we can use a Spring Initializer web page. To build our project, I would keep Gradle as it is here, then Java stays as it is as well, Spring Boot version stays as it is. Then let me just quickly change the project name and a description a bit. Okay, this is done. Now quite important moment. The Java version should be the same as you have it installed on your machine. In my case it's Java 11, so I need to select it here. If you have a different Java version, please pick up the corresponding one, otherwise you would not be able to run your code. And then the last, but definitely not least, are our dependencies. For this tutorial, we would need two dependencies. One is a Spring Web dependency, which would allow us to build our REST API, and the second one is a Spring Data MongoDB dependency, which would allow us to easily integrate our project with a Mongo database. Alright, everything is selected now. Let's click on the Generate button and let's open this project in our code editor. And to do that, we can just simply unzip the generated file and go inside this unzipped folder. Here we can right click on the build.gradle file and just simply open it through our code editor. In my case, it's IntelliJ. It might take some time to build and load all the dependencies. Let's wait a bit. Okay, perfect. We are ready now to write some code. Let's start with the connecting to our Mongo database cluster. It is going to be super easy. Let's just go to the resources package and let's open application.properties file. And by the way guys, Mongo database is a NoSQL database. And on my channel I have a separate video in which I explain what is the difference between the SQL and NoSQL databases, and what are the advantages and disadvantages of both of them. So make sure you watch that video because that video explains a lot of different things which you might not know. The link will be in the description below. But okay, coming back to this project. Let's continue with our application.properties file. Here we need to provide our MongoDB URI. We can just simply type spring.data.mongodb.uri and we can get our actual URI from the MongoDB website. So let's go to our cluster webpage, let's press on the connect button, let's select drivers. Now let's make sure that our driver is set to Java. And here's our MongoDB URI. We just need to replace the password with our actual password, which we have saved before. Let me paste it here, and let me add one more line to specify our database name. And if this database name doesn't exist yet, the MongoDB would create it for us automatically once we try to insert some actual data through our Spring Boot project. Alright, let's try to run this project now to see whether we didn't break anything and everything works as it should. Okay, we don't see any errors, which is good, and we also see some logs which basically say to us that we have been able to connect to our Mongo cluster. This is very good, guys. So now we can continue. Let's create now a class which would represent our collection that would be used to store some data in our Mongo database. And in most of the cases, you would have more than one collection. So let's structure our project properly at the very beginning by creating a separate package for different data models which we might have. Let's just simply call it a model package. And this is a very standard way of structuring your Spring Boot application. You know, all the models, they can just go to the separate package. Simply as that. Okay, now let's imagine that we are building an online shop and we want to sell some products on it. That's why we need a model class that would represent our products, which we are going to store in a Mongo database. And let's annotate this class with a document annotation. This annotation comes from a Spring Data MongoDB dependency, which we have added through a Spring initializer at the beginning of this video. This annotation basically would allow us to map this Java object to the MongoDB collection. Now we can also create some fields to define our data model. Let's say that our product would have a product ID, product name, product price, and a product description. And since a product ID should be our unique identifier, we should add an ID annotation above it. This ID annotation would indicate this field as a primary key for our Mongo database collection. And also, when you have a field annotated with an ID annotation, and when this field is of type string, in this case, Spring Data MongoDB will automatically generate a unique identifier for you during the data insertion process. This is very convenient, believe me, guys. And also, the last thing which we need to do in order to be sure that we would be able to map our data properly later on is to generate some getters and setters. Alright, now our model class is ready. But what is not ready yet is our repository. Again, guys, let's structure our project properly at the very beginning so that we would be able to add more repositories later on if it would be needed. So let's create a repository package. For our product model class, we need to create a product repository interface. And this interface is going to extend another interface called Mongo repository. In this piece of code, our product class, which we have created ourselves, identifies a domain type which the repository would manage. And the string identifies a type of our unique identifier which we have created in our product class. Make sure that these things are correct. Okay, now let me explain you what is the Mongo repository interface. So the Mongo repository interface was designed to simplify the development of the data access layers when working with the Mongo databases. If we go inside this interface, we can see that it offers a lot of different functionalities for working with the Mongo database. It provides various methods for performing CRUD operations and querying MongoDB collections. So it minimizes our need for writing custom implementations for these operations, which is very, very convenient, guys. And now, since we have our model and repository ready, let's just try to test all what we have written so far. Let's insert our first data to our Mongo database. And to do it, we can have a temporary approach which would be using a post construct annotation in our main class, together with a new method which we're going to create in a second. A post construct annotation would allow us to trigger the method below it automatically once all of the beans would be initialized. And inside this method, let's create two different products which would store in a database. Now, let's auto-var our product repository which we have created. And in case if you don't understand very well what does the auto-var annotation does, make sure you watch my other video on my channel in which I talk about the dependency injection in a Spring Boot. The link for it will be in the description below. But okay, coming back to the code. The last bit would be to leverage some magic from a Mongo repository interface which we have extended. We can just simply call a save method which should save the data to our Mongo database, and that's it, we don't need to do anything else. But before I run this code, let's go back to the Mongo website. Let's click on the Browse Collections button. Here you can see that we have 0 databases and 0 collections for now. Let's run our application and let's see what happens after that. Okay, our application is running, which is good, there are no errors. Now let's hit the refresh button. Yep, here's our data which is now stored in a database. The unique ID was generated for us thanks to an ID annotation, and the data was stored as well. This is very good, guys. Now we are ready to move on to the next step. Let's create a REST API to be able to fetch, create, update, and delete this data. And for that, we will create a controller package. And inside the controller package, we should also create a product controller class. This class will be responsible for handling incoming HTTP requests and returning appropriate responses. And to do so, it has to have a REST controller annotation on top of the class. We can also provide our base URL for the HTTP requests which we are going to implement in a minute. Let's say that our base URL is going to be API/products. Okay, now we are ready to start implementing our HTTP requests. Let's start with a simple GET request first. A GET request is in charge of fetching the data. So once someone would call our GET request, let's say that it should return a list of all of the products as part of the response. We need to have a GET mapping annotation, which means that it would be a GET request, and also we need to have a return type as a list of products. And now the thing is, we can write an implementation of our HTTP requests here. However, it's not the best practice from a code design perspective. A good practice in this case would be to create an additional service layer which would encapsulate this application's core logic and would provide reusable methods for the processing the data. And to create this additional layer, let's start with creating a new package called service. And inside the service package, let's create a product service class which would act as an intermediary between the controller and data access layer. We need to annotate this class with a service annotation so that we would be able to inject this class inside our controller. Also, let's auto-var our product repository. And once again, guys, if you're not sure what both of these annotations actually mean and why we need them, make sure you watch my other video on my channel in which I talk about the dependency injection concepts in a springboot. That video would explain you exactly what these two annotations do and why we need them. But okay, now we can create a method to get the list of our products from our Mongo database. And inside this method, we can just simply return product repository.findAll. And findAll is a method from a Mongo repository interface, and it will return all of the products stored in our collection. Now we can go back to our controller and auto-wire our product service class, which we just have created. And inside our GET request, we can just simply return product service.getProducts. Simply as that. Okay, let me remove the post construct logic from our main class, since we already have some data and there is no need to create any duplicates in our MongoDB. And let's rerun our application now. As we can see in the logs, it says that Tomcat has started on port 8080. So if I open the Postman and type localhost 8080 and after that /API/products, as it is our base URL which we have defined inside our controller, and if I hit a send button, we can see that this GET request returns a list of all of the products. Congratulations! We have a working GET request which returns all of our data from a Mongo database that is hosted on a cloud. This is very cool, guys. However, sometimes instead of fetching all of the data at once, you might need to just fetch the data for one particular resource by its ID. Let's implement that as well. We would need another GET mapping. But this get mapping also should expect a product ID which would be coming as part of a request URL. And this product ID from the request URL is our path variable, so we need to specify it here. Now, let's go to our service class and let's implement this second get request. Our new method should return a single product, and it also would expect a product ID as an input. Now, in the best case scenario, the product ID would be legit and we would be able to find and return the product from our Mongo database with this ID. But sometimes the ID might not be legit, or maybe the product was deleted from a Mongo database before that, so our product, which we would try to get from a database, is optional. It might be presented, might be not. And in order to check for this product in a Mongo database, we can just simply call product repository dot find by ID. Find by ID is another method as find all, and this method comes from a Mongo repository interface as well. And now, in case if product is present, we can just simply return it. If it's not present, we would throw an exception. Alright, now let's go back to our product controller class. Here, inside our second get request, we can just simply return product service dot get by product ID. Let's run our code now. Okay, to send this second get request, we can just copy the product ID of an existing product and just append it to the request URL, and just simply send another get request. We can see that we get just one particular product instead of all of the products at once. This is exactly what we wanted. But let's also test what would happen in case if you provide a product ID that doesn't exist. In this case, we get a status code equal to 500. Yes, 500 indicates that there was an issue, but the status code equal to 500 is not very specific code. It basically means that there was an internal server error. But it could be anything, not just the wrong product ID, but a lot of other things as well. Potentially we want to return a more appropriate status code in case if product with this ID is not presented in a database. And to achieve it, we can just create our custom exception as one of the options. Let's create a separate package because we might want to create more than one custom exception, and let's call our exception as a resource not found exception. Now we can annotate this exception with a response status annotation. And we can just say here http status dot not found. So this would return a status code equal to 404, which is more appropriate code in the situations when the resource is not presented in a database. Let's also extend the runtime exception, and let's have a simple constructor. Now we can go back to our service and throw our custom exception in case if data is not presented in a database. Let's test it now. I just will send another get request with invalid URL, and yes, now we get a status code equal to 404, which is much better in this situation. And in case if we test this request with a valid product one more time, we get a status code equal to 200, so it means that we didn't break anything, which is very, very good. Alright, now the part with fetching the data with the help of the get requests is done. Now let's implement a data creation flow with the help of a post request. In our controller, we need to create a post mapping for our post request. This post mapping would be expecting a request body as an input, and this request body would represent the product which someone would want to create. Okay, let's go to our product service class and let's do the implementation of it. This is going to be very, very simple. We just need to return product repository.save. And this is all what we need to do in order to save this product to our Mongo database. And now, inside our controller, we can just call the method which we just have created. And let's rerun our application now. Alright, now in Postman, let's create a new HTTP request and let's set the type of it as post. We need to provide our request URL, and we also need to set our request body, which would represent the product that we want to create. Also, we need to set the request body type to be JSON, because our expected request body is our product model, which we have defined in our code. And Spring Boot would try to deserialize the JSON payload into this specified Java object. So that's why we need to choose JSON here. Okay, before I hit a send button, let me go to our database. Here we can see that we have 2 products stored in our collection. After we send a post request, it is supposed to create one more product here. Let me test it. Yes, we got a status code equal to 200, meaning that the request was successful. We can also see a generated product ID and also the data which we have sent. This is very good, guys. Let me also refresh the database. Yep, perfect, a new product was stored, so everything worked as it should. Now let's move on and let's implement the put request to be able to update an existing product. As you can guess, we need a put mapping for that. Also, we need to know the product ID of the product which someone would want to update. This would be coming as part of a request URL, so let's set it here. Also, as you have seen in one of the previous GET requests, we need to define this product ID as our pass variable. And also, since we need to know with what exactly we are going to update our existing product, we need to have a request body as another input parameter. And this request body would obviously represent an updated version of a product. And as we already have done a few times, let's create a new method inside our product service class. Since product ID might not always be legit, we need to check whether a product exists in our database. If it is present, we can just take all of the values from request body that represents a desired updated product, and we can just set the same values for an existing product. And after that, a save function would update an existing product in our Mongo database. And in case if the product was not found, we would throw our custom exception. That's it. Now let's just call this method inside our controller and let's rerun our application to test it. Okay, we can pick up an existing product from our database and copy an ID of it. Our request URL would look like this. Let's also choose the right HTTP request method. After that, we need the request body of type JSON, and we also need to override some values. Let's basically update everything. Okay, so here's our resource before we have sent a put request. Let's now hit the send button. Yep, request was successful. Let's refresh the database. And here we go. Product was indeed updated. Awesome. And now, the last but definitely not least will be our delete request. We need a delete mapping inside our controller, as you already could guess. We are going to delete by a product ID, so we would be expecting this product ID to be part of our request URL. And as you have seen before, we need to add a pass variable annotation here as part of our input. Now, inside our product service, let's create a new method. The product with the product ID that comes as part of the request URL, this product might exist in a database, but sometimes it might not exist there. So that's why the product will be optional. But in case if it actually exists, we will just simply call delete by ID method from the Mongo repository interface. And in case if it doesn't exist, we would throw our custom exception. Very, very simple. And now let's just call this method in our controller and let's rerun our code. You can see that we have 3 products in our database. So imagine that we want to remove this one. If I would copy an ID of it and would go to the postman, our request URL would look like this. And our HTTP method type should be a delete. Okay, we are ready to send our delete request now. Let's hit this send button. Perfect, we got a status code equal to 200. This is great. And now if I refresh the database, we can see 2 products instead of 3, which means that our delete request worked as it should. Okay guys, so now we have a REST API that supports the main HTTP methods, and this REST API is also integrated with a Mongo database which is hosted on a cloud. That's why let me share some very important information with you now. If you like this tutorial and if you want to see more videos like this one, please give me a like and subscribe. And in case if you want to motivate me even more so that I will be creating a lot of new content, or just if you want to say a big thank you to me, a real big thank you to me, you can always click on the super thanks button which is located just below this video, guys. And yeah guys, this is the end of this tutorial. I hope that you enjoyed it, and I will see you in my next one. Thank you guys and good luck.